Bismillah. Although now today we go to another type of slab. We called it two-way slabs. Firstly, in the first lecture, we talk about the one-way slabs. After that, we talk about the stair, qadirma. After now, we talk about two-way slabs. Here, we talk about two-way slabs. Two-way slabs, as we know, slab is a platform surface, raster, normally constructed in a horizontal, was subjected to a load, self-weight, were applied imposed dead load, or live load. Normally we called it thin members. We called it thin members. Thin members. If you have a slabs, this is we called it thin members. This is we call it thin members. Thin member. Why it is thin member? Since the thickness of the element, thickness we call it T, or sometimes we call it H, is very small relative to other dimension. This is dimension width, while the other dimension we called it length. It's small. This is small, therefore we called it thin element. Thin element. Where two-way slabs, the loads transverse in two directions. Where we have moment here in this direction, this main moment. Also, we have this moment in this direction. This direction, the less direction is main direction, certainly. The less direction كم ترين span. فرضاً شوار بوبيان شوار التاكا أبيتا main span شو كان زور لو ذاك direction أروح. This is the main direction, while the other direction we have also this direction. We have two directions for transverse moment and loads. Behaviorally, two-way slab, we have different method to analyze the slabs. Slab is one of the structure is indeterminate. دائما support man مثل four wall here. If we have this slabs, this is the slabs. These are maybe beams or maybe walls. Maybe beams, maybe walls. This direction, the longer direction, we call it long direction. This is longer direction, we call it L. While the other direction is short, we call it W. Width. Sometimes we write L long to L S and short. L long or L short. If we apply the load gradually, توزع اللود بخينا سري. تشيلو أداة. كيف behavior زين شلون behavior. أو لا درجة أو لا كرتكة. يا كمين جار when we apply the loads, يا كمين جار cracks occur in this way. If we load it gradually, crack نيا. Firstly, no cracks. After a steps of loading, increase the loading, the cracks occur in this location. لينا crack رودا. أو سلابا كمان باسم سلابا. After, if we increase the loading, still increase the loading, تمشاكين crack ليرة بيربي. ليرة at bottom, ليرة at top أو أنا toppen. ليرة at bottom. باشا. ليرة at bottom بنو بيربي. وليرش بيربي للتوب. باش. At bottom بداش لان رسمك at bottom وأنا at toppen. After they increase the loading, if it still increase the loading, the behavior goes this way. At top crack continue, بردوامة بيت crack كان وات the bottom is in bottom sometime go here. This certainly depend on the dimension of the slabs. These are at bottom where failure appear in the line, failure occurred in this way. If we applied uniform distributed load, أجر uniform distributed load applied, أو behavior the behavior of the slabs. Now slabs slabs, I want to find the ISA requirement for the slab. Well, we have different methods. Now I want to talk about the analysis of the slab. We had different methods to analyze of the slab. For example, we have yield line theory. Second, we have strip theory. Well, we have direct design method. Well, we have equivalent frame method. Equivalent frame method, and so on. We have this one or another method. We have coefficient method. This is the simplest one. We depend on the tables. We depend on the tables. In this chapter we talk about the coefficient method. How we can use a coefficient method. We have 3 tables and depend on the we can find the moment in here. Moment in any location is equal to coefficient times WL square. دائما. Coefficient, this is coefficient. WL are noun. W now, no, L is R now. Maybe L short direction, maybe L long direction. Now, where U is uniform distributed load over square meters. Coefficient, how we can find this coefficient? We go to the tables. We have a coefficient. Tables. This is the simplest way. We have a tables. This tables found by one of these methods, especially yield line, were divided. We have the coefficient for negative or coefficient for positive. And then coefficient for negative moment. See here, then in the slab we have the direction LA and LB. Let me draw the slabs. This is one of the slabs. Maybe continuous, maybe not continuous. اعتمادك هسه شو أنا كمان. Location. This is dash line. This distance, we call it LB. The longer distance depends on the. We go to the table. أشمعناه table كمان. This distance, maybe we have a wall here or beam here. This distance we call it LA. إذا LA مان هي و LB مان هي. LA مان هي و LB مان هي. LA مان هي و LB مان هي. LA is short direction, LB is long direction. Here we have M is LA over LB, short over long. Well, it's clear, صافي, clear. From face of the beam to face of the beam, or face of the wall to the face of the wall. Here is also. We have different support case. We have a case 1, or case 2, or case 3, or 4, or 5, or case 6, or case 7, or case 8, or case 9. I'm case أنا تشين. I'm case here. أما بيشارة ده simply supported on 4 sides. Not table كمان. It's simply support on 4 sides. Here, put in this direction, this symbol, we put these symbols. This means that continuous in this direction, continuous in this direction, continuous in this direction, continuous in this direction. Like interior support. This, like this beam, continuous in this direction, or continuous in this direction, continuous, or also continuous in the other directions. Well, here, case 3, we have the slabs supported on 2 short directions. 4 supported in this direction and in this direction. 5 supported on long direction. Or not supported on 4 sides. Continuous in this direction. Continuous in this direction. Continuous in this direction. باشا. و6 تنها يك direction معناه continuous. يك direction معناه continuous. و7 one direction continuous. 8 we have 3 direction continuous. و9 we have these direction 3 direction continuous. I'm case this direction continuous, this direction continuous, this direction not continuous, this direction not continuous. Let me go to the table. It is case 3, case 4. It is case 4. I got here. It's case 4. Well, we have different ratio of A. We have one ratio of L over B. We have CA or CB. CA short direction, coefficient, this coefficient A or coefficient B, CB. Basha, coefficient A or coefficient B. I have in short direction, we have 0, nothing. Here, simply supported, moment 0. Here, continuous on 4 sides. Then, in short direction, the coefficient is equal to 0.045. Well, in long direction, coefficient is equal to 0.045. Here are equals. Well, we have 0.9F. The ratio of LA to LB is 0.95. Here is equal. Here is equal to 0.95. We have 0.9. We have 0.85. We have 0.8 also in the tables. Well, until we have 0.5. The increment is 0.05, 0.05, 0.05. We have a different value for this. This is 0.9, 0.95. For example, here are not equal 0.05 in the short direction. But in long direction is equal to 0.041. Long direction كم ترى is less than long 0.041. إذا هو متكبم direction كاتا 0.041. أكا 0.041 WL square. In this direction أكاتا 0.05. In this أكاتا 0.05 WL square. زانا ها توانين متكبم زيت. Now this is table coefficient for negative moment. Well, also I have table coefficient for you have coefficient for positive live load moment. The positive I got a double divide into part. The positive moment divide into part. Due to live load or due to dead load? Due to live load, we got it due to dead load. Due to live load. Then we have another table. This is another table coefficient for negative dead load moment. This is positive. Well, this is negative. Sorry. Yes, for positive. Positive divided into 2 parts. Negative, it's 1 part, 1 table. For example, I show you, this is the tables, this is M, LA over LB, and this is a supporting case or continuous case. This is simply support on 4 sides, or this is supported continuous on 4 sides. Well, these are the coefficients. This is just for negative moment. For positive moment, we have 2 tables. This table for positive dead load positive moment. Dead load positive moment. Another table here, another table found for positive moment just for live load. These are coefficients used for live load. These are coefficients used for live load. استاجر بكرة الراي بس بمؤقتين باش كان برسياج حلقين طايق. Now is the thickness how we can find the thickness of the slab. How we can find the thickness of the slab. According to the ACI code, we have a thickness, شلون نتوين thickness those, you know? We have if alpha is more than 2, we have different equations. بس اما باسك كان صفي شوال مرحله هيك بس والله يسلم مرحله ك normally alpha is more than 2, alpha is equal to stiffness of B هم تنازع stiffness يعني EI over L 4EI over L over stiffness of slab. Stiffness of slab normally is more than 2. Normal. Therefore, if it is more than 2, if it is, we can find the minimum edge depend on this equation. L n long. This is we call it Ln long in the long direction. N clear. Nominal length clear. Safi. From here to here. Feeling clear. L n short. Here L is equal to L n long. Short or long. Then Ln long O is equal to 0.8 plus Fy over 100 over 36 plus 9 beta. Beta is equal to what? Beta is equal to Ln long over L n short. Inverse to this case, opposite to this case. Oh, this case M chiakat, this we call M. Short over long. Here, nakher. Beta is equal to long over short. Depending on this equation, we can find the thickness of the slabs. This is first. Second, the minimum AS for the reinforcement. This is at bottom, this is at top, in any direction, minimum reinforcement, AS minimum, according to the ASI, 0.0018 times B times H. This is first. The second, the spacing between the bars, maximum spacing between the bar must not be less than 2 edge 2. Here is 2. In 2-way slab is equal to 2 or edge of second of slab or 450 millimeters. Maximum spacing must not be more than 2 edge or 450 millimeters. Is the right باش كتر ولدو قيسي خوي هي وري ناقرين أولا كاتي خوي بدك مرحلة الوريق إن شاء الله. Now we go to solve example on two-way. This is third example on two-way slabs. We have this frame. We have this frame. The request of the problem is to. We have the slabs. This distance 5 meters. Wow, this is trial. We have column here. We have column here. Center is. Meter, or here is 5. From center to the column to center of the column is 5 meters. Now, vertically, from center of this column, we have 6 meters. This is 6 meters. Also I have 6 meters in this direction. In this direction, we have 6.5 meters. Now it's required to dash the slab is similar. دائما يكس هاو شوية سلابي طابق يكم طابق دوم طابق سيم طابق بينجم طابق بيستم فرضا همي اوفيس همان سلاب دسكه وسلاب بخوي بقوته كان فور سبورتي هي نبرو بقوترين ممبر الستراكشر كاخر شي برو خيط سلابا ما قال خراب تصميمي كنزور كان we have each slab have 4 support بينما beam have 2 supports بتشابوا الراس ديتي the most critical member is column after that footing These are dash line represent the beam. The dash line represent the beam. The column must be bold in order to show the location. The column must be bold. It's better to be bold. The column must be bold. Distance كان ما نزاني design the slab. We can also this require design the slabs or design the slab. Here we just try to solve this example. أتواني بس example بس we try to solve this example. The given problem, the given requirement, live load 250 kilogram per meter square. Suspending ceiling is equal to 16 kilogram per meter square. FC prime 28. FY 420 megapascal. Beam dimensions, all beam dimension is similar. Beam dimensions is سيصد times شصد. Column dimensions, all column dimensions 400 times 400 millimeters. Slab thickness not given. We try to find the slab thickness. Now, not given slab thickness, we try to find the slab thickness. Mortar given also load for tile and mortar. Tiles 20 millimeters. Mortar 60 millimeters. And gamma for this is equal to 23 kilo Newton per meter cubic. For tile and mortars is equal to 23. Okay, this is solution. I go to the solution now. Now I want to find the thickness of the slab. شلون thickness of slab does you know? أما شش في بينجم panel. This panel char في شاشة. Which of them is the largest slab? This is largest panel. 5 times 6.5. Therefore, the thickness must be constant for all slabs. I go to the critical slabs. Critical slab, Gauratrin slab later. And designed for this, while the thickness for all. I go to the critical section. Then I go to the to find thickness. I go to this slabs. Then ln long over ln short, ln long, L long over L short is equal to, for this slab, is equal to 6 over 5. This is less than 2. This is two-way slab. I check the slab is two-way slab. This S1 is two-way slabs. Less than 2. If it is more than 2, it's one-way slab. This is first. Now I go to find the thickness. Now I go to find the thickness. Find the thickness of slabs. We depend on the critical slab. This panel, as we say, this is more largest panels. ln long, ln long is equal to what? Long, akata 6.5 clear minus the thickness, the center to center, minus the width of the beam. Width of the beam 0.3 over 2, 0.3 over 2 on each side is equal to 0.3 over 2 minus 0.3 on each side. Here is equal to 6.2 meters. ln short, same. Ln short here is 5 meters. 5 minus 0.3 over 2 minus 0.3 over 2 is equal to 4.7 meters. Now I go to use the equations. Edge minimum edge is equal to what? Is equal to ln long 0.8 plus Fy over 140 36 plus 9 beta. Beta is equal to what? Is equal to ln long over ln short. Yani 6.2 over 4.7. And this is equal to 1 point. This is equal to 1.319. Now substitute here. Substitute here. Long is equal to 6.2. 0.98 plus Fy 420. 140 constant from the equation. 36 plus 9 beta. Beta is equal to what? 1.319. Minimum thickness, we must use it in this problem, is 0.142. Minimum thickness 0.142 and شهادة سنتي يعني 14 سنتي. Therefore use edge is equal to 150 millimeters or 0.15. 150 millimeters. Even this is, we found the thickness of the slabs. We have dead loads, we have live load, we have dead loads. Here the live load is 300, sorry. The live load is 300, sorry. This 300, sorry, this error. The live load is 300. Now, dead load, we found the dead load, summation dead load, as we do in the first example. Go to the slab, one-way slab. Same example. We take the summation of these loads, we found the loads. How we can find this number, 6.04, we go to the example number 1. Live load is 3. Now, live load is 3. earlier last. W is equal to 1.2 dead, 6.04, plus 1.6 live, KXN number 3, here is equal to, now I want dead load is equal to 1.6 times, so I got a half point do زائدا 12.8. This is due to dead load, this is due to live load with factor loads. Total is equal to 12 kilo Newton per meter square. Here two way slabs. Now I go to design the critical slabs. Now I go to design the critical slabs. Now I go to design the critical slabs. The load, we found the loads for the slabs. Now I go to design the slab S1. Design slab S1. Ln is equal to what? Ln. Ln long is equal to 6 minus 0.3 over 2 minus 0.3 over 2, and this is equal to 5.7 meter. Ln short is equal to 5 for this slab. 5 minus 0.3 over 2 minus 0.3 over 2 is equal to 4.7 meters. Now we have also Cm. M, we have value M is equal to Ln. A, this we call the Ln. La, short, Lb. Well, this is called to La in order to go to the tables. La over Lb is equal to 4.7 over 5.7. And this is equal to 0.82. Now we have the depth of the reinforcement D. We put the main reinforcement in this direction. Main reinforcement we put in this direction, short direction. In the slab, short direction is very important, more important than long direction. Reinforcement put in load transfer to the short direction. Zortrin load transfer to the short direction. Where D is equal to what? Thickness of the slab, Satu Punjab. Cover 20. We use 5 downza. Even 12 over 2, 5, 12, and this equals Satu is to 12 millimeters. This is called D1. D2, the reinforcement, we put it in this direction. In this direction. In this direction, this direction. The reinforcement, we put this above the others. يعني الرسمة كي بكم. This is long reinforcement. In the short direction, in the long direction reinforcement, we put it in this direction, this way. Whereas this is extreme side, external side, extreme side. This is this distance, we called it D1. The other distance, sorry, this is the thickness of the slab. This is the thickness of the slab. Here, from here to here, we called it D1. From here to here, we called it D2. This is the thickness of the slab. Thickness of the slab is equal to edge. We found it is equal to 150 millimeter in this problem. Satu Punjab millimeter. Then this is the reinforcement. We take a section of the beam, call a slab, section of the slab. This is D1 or this is D2. D2 in the other direction, we put the reinforcement in the other direction, this direction. In this direction, in the longitudinal direction, is equal to what? Satu bis 2 minus 12 over 2 minus 12 over 2 minus 12 over 2 or minus 12 over 2. This is 12, this is 12. Is equal to Satu 112 millimeters. 112 millimeters. Sure. آخر أكا يكجار ناقص دوانزا كاسة بسوا يكجار over 2 over 2. Now AS minimum, don't forget AS minimum must be the reinforcement must be more than AS minimum. AS minimum is equal to what? 0.0018 times B times H. When you times B times H. AS 0.0018 B 1000 for the slab design of slab 1001 meters times edge 115 is equal to 270 millimeters square per meters. Maximum spacing here to edge into Way Slab to edge, or kx ana to edge 2 times 300 is 150 is equal to 300, or 450 millimeters. We can find the distance for this also. Now I have to go to use the coefficient and analyze the slabs. Here I have positive moment. Here I have negative moment. On the same page, we do analysis for positive and negative moments. Here we have date load in moment separated into two parts. We have date load and live load. Date load, this is for date load, is equal to date load, factor date load 7.2. Find the moment. Well, live load is equal to 4.8 kilonewton. Here, the loads W for negatives W is equal to 12 kilonewton per meter square. All for kilonewton for meter square. Kilonewton for meter square. Here we have, after we do for positive and negative, we have summation. Here plus here. In each direction we have two directions. We have short direction and long direction. The factor is this coefficient is 0.82. Then for M, we have M is equal to 0.82. In the table, hamana for 0.8 and 0.85. 0.8 and 0.85. Okay. Another thing it's required also, M is another thing it's also required to mention it. The date load or live load or mention شتتريش مهمان هي M وشي مان في شتيكيش مان مهم هي negative moment 0.2 okay, let's go to continue. نات ماشكم لو لحظة M 0.82. The table like a chuchi man here in the tables. Case, yes. Very important case. This is which case? Case of support, continuous. Case of continuous. This direction continuous, short. This is continuous, this is continuous, this is not continuous. Then we have this case. For both, certainly for both. We have this case. Here continuous. This is also continuous. This is also continuous. This we call it case 4. If we go to the table, case 4. Case 4. Case 8. Case 8. Sorry. Case 8. We observe it. Which case is confined on this? Which case is comfortable with this? We choose that case. Here is case 8. Yes. Zor Basha. I go to the tables. Now I'll show you the tables. Now I go to the coefficient. We have this is 0.82. We have a factor for 0.8. for 0.8, M 0.8, or M 0.85. And we have X exana 0.82. X is equal to 0.82. I have short direction, or I have long direction coefficient. Short direction, long direction. In this direction, direction A, I go to the tables. This is for negative moment. Here for 0.8, for example, I go to 0.8. I go to the 0.8. This is 0.85, 0.8. We go to the case, our case in the example, 0.8. Here, 0.8 is equal to the coefficient in short direction is equal to 0.055. In long direction is equal to 0.041. This is for 0.8. And for 0.85, case 8, 0.049, this is negative one, or 0.046. Case 8, this is case 8, or 0.85 or 0.8. Now I substitute this value here. I substitute this value here. Oh. I go to here, this case, for 0.8 in short direction is equal to 0.055. In long direction is equal to 0.041. For 0.85 in short direction is equal to 0.049. لا تنسى 0.9 باخذ 0.85 ماشي 0.9 باخذ 0.85 و this is equal to 0.046. Now this is unknown x1 unknown or x2 unknown. x1 we can find by interpolation. x1 is equal to 0.0526 by interpolation, or x2 by interpolation between these two values equal to 0.043. 0.043. By interpolation we found this value. Basha, we found this value. Now I go to find the moment in this direction. Mn is equal to what? Ma or Mn is equal to what? Is equal to coefficient W square times Lu square. Li. Coefficient here 0.00526 times U 12 times L in this direction Ln short is equal to what? Short is equal to 12.7 square. 12.7 square. 12.7 square. واضحة 12.7 square. زور 12.7 square. And this is equal to سيانزا 0.9 kilo Newton meter per meter we take for each meters. Now I can also find the moment in this direction. MB in the long direction is equal to coefficient B, this coefficient A, times W L B square. CB, we found CB. This is CB. Times U12 times span. Here the span, pinch point half. Long span, pinch point half square. Pinch point half square. إذا the moment MB is equal to what? Is equal to شانزة point half tau 6 kilo Newton meter per meter. Now design for the section. Design شو كاين؟ as we know سيانزة point neutral tends to power 6 بس بيجي كانكم. يكسانا phi AS FY in this short direction D. In short direction D is equal to D in short direction. Short direction. D is equal to شو R. ناقصا AS FY over 1.7 F prime C times 1000 times 1000 hazard. Width of the beam hazard, slab hazard for 1 meters. Now we found AS. كده كان AS سياسته شو R. millimeter square per millimeters per meters was divided by area of 1 bars phi 12 أكات 2.7 bars per meters. Now hazard دابش 2.7 أكاتشن أكا سياسته حفتا millimeters center to center. Here the minimum, the maximum spacing سياسات. إذا minimum control must not be more than 300. Must not be more than 300 according to the ACR requirement. إذا use phi 12 at 300 millimeter center to center. Okay, this is the first. The second, also we use the same procedure, 16.76. Just in the D, we use here in the short direction. Short direction. 1, 1, 2 minus. In the D, we use D2. Don't forget, in this direction, we use D2. The reinforcement here, in this direction. Above the main reinforcement, above. Above the reinforcement in the short direction. Boya beta satu duanza. AS, we found AS is equal to char satu. No. طاوة. بابا ليه نسرع؟ لا رسمك. char satu no divided by 113 if we use phi 12 is equal to chan. Say point. Just to do bars per meter. هر متر say point just do bar إذا 1000 divided by say point just to do أكاتشن. دو سطو حفتا وشش مليم. إذا use phi 12 at دو سطو بنجا مليم سنتر دو سنتر. أتوين دو سطو حفتا وبنجا بجري. بس use دو سطو بنجا متر سنتر سنتر. واضحة؟ إذا negative reinforcement. These are negative reinforcement. These are negative reinforcement. I also do the same thing for positive reinforcement. In positive we have two tables. We have two tables for dead load. For dead load and for live. For dead load, this is first for dead loads. For dead load, we have case 0.8, 0.85, similar idea. 0.8, 0.85, we go to the case number 8. We have these coefficient. This is for 0.8, the other for 0.85, the above for short direction, the other for long direction. These directions, coefficient is equal to 4.8, 4.85, 0.032, 0.029, 485, x is equal to 0.82 is equal to what? Interpolation? 0.308. In short direction, 0.0 fazla 0.0 hafda 0.0 satu panjab. Now I go to continue. We found all coefficient method. 4.8 for live load, 4.85. Now for x, 0.82. Similarly, I go to the tables. I show you quickly. Now for live load, This is for live load. Show you quickly. This is for live load. 0.8 or 0.85. Case 8, we have these two coefficients. We have these two coefficients. 0.8 or 0.85, we have these two coefficients. The above for short direction, the lower for long direction. أما بقولش لا كورتكيا أما لا دريجكيا أما لا كورتكيا أما لا دريجكيا. We found also for 0.8 or 0.02 char 0.0 char in between char satu short direction 0.0 nozda 19 22 in between interpolation. After interpolation, we found these values. Now, the moment here in the short direction is equal to coefficient A times live load W due to date times LA square times LA square. Coefficient 0.0308. This is short direction. Don't forget short direction. Times W. W is 7.2. Date load. This is just for dead load. This is just for live total wind load. Then times span 4 point short span square. Moment is equal to 12.9 kilo Newton meter per meter. In the long direction MB, same thing, CB, W date load times LB square, LB square. The coefficient 0.0158 times W 7.2 times span, the span, long span 5.7 square. منتكشنكات 7.7 kilo Newton meter per meter. Use the same idea here. MA. I finally found Chanaka Muntakatali. 4.5. MB. 3 kilo Newton meter per meter. Also here. Now we found the total moment MA. Total moment MA in short direction is equal to this plus this. This plus this in short direction. 4.9 due to date و 4.5 due to light is equal to Chanaka 0.4 kilo Newton meter per meter. Short direction MA, MB, short direction, this is short, long direction, sorry, long direction 3.7 plus كواني 7.5 أكاد شنك كان 6.05 kilo Newton meter per meter. We can find AS, we can here found AS is equal to do satuchar. AS we can find for this moment. AS for this moment we can find also AS in long direction chanakat satu shastuchar. Per meter. As we see is less than 2.5 minimum must be more than or equal to 2.5 AS minimum must be more than or equal to 2.5. Either we use 2.5. Either we use 2.5 millimeter. This is minimum control. Minimum control. Well, this also minimum control. Just we have this reinforcement. Then we use minimum control سياسات. We use phi 12 as سياسات here. Here is also we use phi 12 at سياسات millimeter center to center. Phi use phi 12 at minimum control. Use phi in this direction long, phi 12 at سياسات millimeter center to center. Millimeter, sorry, center to center. Russia. Here we must also found the distance between the bars. We get more than 300. We get spacing here more than 300. Now I transfer this calculation to the figures. This is very important. Our design, our calculation, our efforts transfer ما عندي بقول ما هم تحويل لكن بالرسم يمتنيش الرسمه. For slab S1 here slab S1 يا خما لا يكمل بوي لما تيكل this S1. We have reinforcement at bottom. At bottom. We have reinforcement at top. We use cut bar بكاردي. باش بوكو بيم cut bar. واضحة؟ أما ناينين this is plane. We have also cut bar كهمنا بشك يكينا cut bar هم تانا زين cut bar we use additional bar. This is we use our Bacardianine this reinforcement we use R1 yeah. Well, this reinforcement is R2. What's R1? Now I explain what's R1. This is R3. This is R3. Now also I have reinforcement in the other directions. This is we have these are at bottom. We have also negative at top. Or negative at top. Negative at top or negative at top. R1 channel. R1. We use R1 channel at R1. I put R1. I try to write here. 5 12 at شصت millimeter center to center. We found from the calculation سياسات. This is we put شصت. What is شصت? وهيك ترجع تنجي داني شصت يعني أو هذا alternative داني يكيو جاي كتير أو هذا داني. يعني أقل الرسم كم? This is at bottom. What is also at bottom. Now this is 600. What is 600? This is 600, but in between we have this bar. What is 600? What is cut bar? أبيت سياسات. أقعد ليه؟ أبيت سياسات. At top R3, R2 إيش؟ cut bar كه R2. 512 at شصت millimeters center opening cut bar. أما peeling continuous bar at bottom. طاوي إيش هذا؟ إيش at bottom. But this is also at bottom. This is also at bottom. واضحة. R3 512 R3 is additional bar at top. 512 we found minimum here is equal to 250 for negative. For negative شو underscore 250. For this direction نخير. For this direction is at سياسات. إذا at سياسات. هربة تانية center to center filling additional bars. Well, certainly this is at top. This is at top. At top. Now I have another reinforcement in the longitudinal direction or in long direction. Here is R1. Here is R2. This is R2. This is R2. Let me R2. Just that this is R4. What is the difference R4? واضحة؟ This is R2. What is the difference R4? R4 is phi tail at 250. Minimum is not control. It's not control. We found the results. 250 in the long direction, not in the short direction. Direction. In short direction, this is in short direction. This is in long direction. In long direction. Was equal to R4. R4 is what? At center to center. This we call the additional bar. At top bars. I think everything is finished for this problem. إذا أنا همش تكتبوا for this problem.